So welcome everyone to this seventh MARCOGAZ Tech Forum. This time we will be discussing the application of the EU regulation on methane emissions reduction. My name is Virginia Sanchez. I am Communications and Strategy Manager here in MARCOGAZ. And today we have ahead of us 1 hour and a half with great presentations. And the event is being recorded. And both the recording and the presentations will be made available very soon in the MARCOGAZ website, and also we will send every registered people to an email with these materials. During the presentations of today, please feel free to put any questions that you have in the chat. They will be collected and they will be addressed during the Q&A session. We'll have plenty of time after the presentations to address all of them. And well, with no further ado, I would like to first introduce you to Alexander Swanser, which is the MARCOGAZ president, who will open the webinar. Alexander has been member in the MARCOGAZ board since 2008, and he's president of MARCOGAZ since June last year, after 2 years as vice president. In Austria, he's head of the certification body at the Austrian Association for Gas and Water for products, people, and companies in the gas, water, and electricity sector, as well as a representative for European gas affairs. He is active in the industry for more than 25 years, and he is an experienced strategist with an extensive network and wide-ranging expertise in the gas and water sector. And he serves on several committees and groups in the Austrian standards, CEN, and also, of course, MARCOGAZ. So please, Alexander, the floor is yours.
Thank you very much indeed, milady. Thank you, Virginia, for your kind introduction. And welcome, dear ladies and gentlemen, to our additional webinar this year on the EU methane emissions. So, ladies and gentlemen, to begin with, we want to approach the topic of methane emissions with some general facts, please. So the next slide, please, dear Virginia. So, which means worldwide, almost half of methane emissions come from agriculture, with around 45%, followed by the energy sector in the second place with just under 37%, while a sector that you probably do not think of first also plays a major role at almost 20%, and since the emissions form the world's quantity of waste. And it can be said that global methane emissions have increased. The reason for this global trend are not yet fully understood, and there are also indications that permafrost and wetlands may play a larger role in methane emissions in the future. At the same time, reductions have been achieved in some regions and sectors. Examples of successful methane emissions are that in the period from the 1990s up to almost now, the share of methane emissions in total greenhouse emissions in the EU fell by almost 40%. And for instance, regarding the region mentioned, Germany has reduced its methane emissions for more than half since the 1990s. Part of this improvement can also be attributed to the gas industry, which probably has a natural interest in not losing its product and damaging the environment in the process. Emissions along the value chain of natural gas fell by almost 60% across the EU in the same period, despite an increase in gas consumption by a quarter and significantly longer gas networks. And with the entry force of the EU Methane Regulation in the last year, in August, methane emissions from the extraction, transport, and the use of coal, oil, and gas are to be reduced by a further 30% by 2030. The regulation introduces new requirements of the measurement, reporting, and verification of methane emissions in the energy sector. In addition, methane emissions are to be avoided through emission reduction measures, such as the detection and repair of methane leaks, as well as costly venting and flaring. Furthermore, global monitoring tools are intended to ensure transparency on methane emissions from all gas and coal imports into the EU. And here's some key words, or better say key activities for the operators, such as the measure methane emissions at source, prepare monitoring reports, the conduct of independent audits, maintain inventories of all wells and emission reduction plans, measure and monitor emissions from coal mines, the conduct of regulatory inspections by government bodies, and detect and repair methane leaks within specific timeframes to prohibit venting and flaring of methane within certain expectations, of course, and the monitoring methane emissions from the EU energy imports by third parties. And this is where the MARCOGAZ comes in with its report. This new document is intended to provide relevant information and support the implementation of regulation requirements into policies, of course, and strategies for individual operators and companies regarding methane emissions, ladies and gentlemen. And at this point, I would like to hand the floor back to our kind moderator, Virginia, and our next speaker.
Thank you very much, Alexander, for this opening of the webinar. And well, we go to the first presentation. We have with us Tomás de Oliveira, who led the analysis on methane emissions in the International Energy Agency's World Energy Outlook 2024, and was the lead author of the Global Methane Tracker 2024. Prior to his arrival in the IEA, he worked as a policy officer also in the Brazilian Institute of the Environment and Renewable Natural Resources, and he is an environmental engineer with a master in public policy strategies and development, and he will introduce us for a more global perspective on the methane emissions mitigation. So please, Tomás, the floor is yours.
Thank you, Virginia, and thank you very much for the kind invitation to present at this event today. So I'll be speaking a little bit about the Global Methane Tracker 2025, which I was also the lead author, and that we released in May 2025. And what the report does, and together with the report, there's a data tool, is we present our latest sector-wide emissions estimates. And these are based on the most recent data from satellites and measurement campaigns. And we discussed different abatement options, the status of reduction efforts, costs, investments, and related information. So if we can move to the next slide, the first key message that we should all have in mind is that alongside record production of oil, gas, and coal, we have essentially, a very high level of methane emissions, around 120 million tons annually. And this is because you have some amount of mitigation efforts, but these are not strong or comprehensive or broad enough to really drive down these emissions in face of the increases in production. In relative terms, methane concentrations in the atmosphere have been rising more quickly than those of all other major greenhouse gases, and at a rate faster than in any period since record keeping began. So this is really a worrying trend. This growth is mainly due to mounting emissions from human activity, such as, for example, oil and gas production, distribution and use. But there are also indications that a warming climate is driving up emissions from natural sources, such as wetlands. Agriculture and waste sectors are major sources of man-made methane emissions. We heard this from the first speaker. But tackling emissions from fossil fuel supply offers the greatest potential for immediate reductions in methane. That's something very important that we need to have in mind. Solutions that lower methane emissions from oil and gas, for example, to near zero already exist, and many of them could be deployed today at little or, in some cases, even negative cost. We estimate that around 5% of global oil and gas production currently meets a near zero methane emission standard. And there are good reasons to work on raising that share. If we move on to the next slide, we can outline some of these reasons. I mean, first of all, methane is such a potent greenhouse gas that if we manage to reduce methane leaks, we can really make a big difference for action on climate. Under existing trends in fossil fuel supply, strong action to reduce methane emissions would prevent a roughly 0.1 degree Celsius rise in global temperatures by 2050. This would really have a tremendous impact. It's comparable to eliminating all CO2 emissions from the world's heavy industry in one stroke today. But there's also a strong energy security case for tackling methane leaks and gas flaring. Cutting down on methane and flaring can help improve energy security and ease the supply-demand balance by bringing additional natural gas to markets. Around 200 billion cubic meters of methane was emitted by the fossil fuel sector globally in 2024. Not all of this could have been captured and used as energy source, but we estimate that abatement could have made nearly 100 billion cubic meters of natural gas available to markets. And that's roughly the same amount that Norway exports. A further 150 billion cubic meters is flared globally each year. And most of this is routine or non-emergency flaring. So addressing both flaring and methane in tandem would facilitate, create synergies, make it more possible to deploy the solutions and ensure greater volumes of gas reach markets. And if we go to the next slide, a bit of there are many options to reduce methane emissions in the energy sector. In oil and gas, for example, we see that leak detection and repair is a very important solution. You can deploy vapor recovery units to recover gas with low pressure and put it back in pipelines. You can deploy, for example, dry seals and compressors that would then replace wet seals, which essentially emit by design. And there are also opportunities to reduce methane emissions from coal mines and in the bioenergy sector. If we sum all of those together, we could reduce methane emissions globally from the energy sector by around 70%. And if we go a bit further to the next slide, we can see that momentum to drive down methane emissions has continued to grow following the launch of the Global Methane Pledge in 2021 and the Oil and Gas Decarbonization Charter in 2023. Today, most countries have pledged methane reductions through the Global Methane Pledge or national action plans, with some notable exceptions. We can mention Algeria, Iran, Russia, Syria, Venezuela, but most of the emissions right now are covered by methane pledges. And while this is very good, only a fraction of these are underpinned by robust policies and regulations. We estimate that under current settings, oil and gas methane emissions would fall by only 25% by 2030. And this falls short even of the Global Methane Pledge goal to cut total methane emissions by 30% by 2030. And bear in mind that reductions in the oil and gas sector are much easier than elsewhere. And so they likely need to fall much more than 30% so that we can achieve the overall Global Methane Pledge goal. If we look at the right side here of the chart, we can see that around half of the global oil and gas industry has pledged to near zero methane emissions by 2030. In 2024, we saw PetroChina, Asia's largest oil and gas producer, joining the Oil and Gas Decarbonization Charter. There were 18 new companies joining the Oil and Gas Methane Partnership, including NNPC and Pertamina, some very important ones. Some companies have joined both these initiatives, others are engaged in other initiatives, but it's important to think about the overlap between these two charts. Large part of the industry seems to be closely following policy signals. Only around 5% of global oil and gas production is covered solely by industry pledges. And absolutely, pledges are very important signals, but we need to see countries and companies showing verifiable methane reductions. And this is just very much the exception rather than the rule right now. If we move to the next slide, we can see that the industry as a whole has made some progress in lowering its methane intensity, or in other words, improving its performance in the last years. there's been about a 10% reduction in the upstream emissions intensity over the past 5 years. So that's the amount of methane that is escaping by the amount of energy that you are producing. But as I mentioned previously, with continued growth in oil and gas production, the absolute level of emissions have remained very high at around 80 million tons per year. And part of the reason for this is that the performance among the industry varies widely. The best performers are about a factor of 100 better than the worst. And if we just deployed readily available solutions and technologies throughout the industry, we could have a 75% reduction in emissions. And this would very much be consistent with near zero methane targets. So in our view, the oil and gas industry needs to move beyond intensity improvements to absolute reductions in emission levels if it is to deliver on its pledges. And reducing very large sources of methane emissions, such as those detected by satellites, would be a good initial priority, though certainly not the only one. So going to the next slide, if you can click, we can see here a bit of information on satellites, right? Today, we have more than 25 satellites in orbit that can provide insights on methane emissions. A number of new methane-focused satellites became operational last year, including MethaneSat and Tanager-1 from Carbon Mapper. They have high resolution, they provide data over wide areas, they have sensitive detection thresholds. But the data that you're seeing here on the screen is from Sentinel-5P and the TRPOMI instrument. And it's one of the few satellites that offers a global view of methane emissions and that has been operating for a number of years. It only sees very large leaks, and these are not falling. Emissions from these very large sources rose to a record level in 2024. And this was despite the fact that there was a lower number of days where observations were possible. Most of these emissions are tied to a few regions, for example, oil and gas bases in the United States and Turkmenistan and Russia. But there's a wide range of emissions coming from different countries where satellites can make observations. And these are all related to oil and gas operations. Now, if we move to the next slide, we can see a bit of some of the opportunities to reduce these emissions. We, as ever, took a detailed look at the requirements, the cost of infrastructure, and the cost of equipment, and operationalize solutions to cut methane emissions. And this includes whether or how any captured gas can be brought to market, for example, by a compressed natural gas truck, a new pipeline, or other means. And we should acknowledge that in some cases, the gas is stranded and can only be dealt with by reinjection or even flaring in some cases. But there are many opportunities to reduce methane emissions, and these are often provide high rates of return. So if we look at the chart here, what we see is that many measures that have internal rates of return of above 25%, which is more than the usual rate that companies consider when making spending decisions. These measures, they could reduce over 13 million tons of methane emissions in the oil and gas industry. Some of the highest return options are leak detection and repair measures upstream, or uses of vapor recovery units in tanks, for example. And so the question that immediately comes to mind is, well, if this is all cost effective, why isn't the industry harnessing these opportunities more? And there are many reasons. We can speculate on a few. Certainly the situation will vary between companies and around the world. But some of the key issues is that sometimes the capital requirements are too small to grab the attention of the board when making investment decisions. In other cases, companies are not fully aware of the scale of the problem or the available solutions. And if you are, for example, in the context of cash-strapped NOCs in developing economies, then external financing support might be needed. Government, regulators, but also the industry and the society at large have an important role to play in helping overcoming the hurdles that exist. And I think having an open dialogue with the industry is crucial to finding the solutions. With that, I'd like to just close. I think when we look at the global picture, more than 40% of global oil and gas supply, and close to 20% of natural gas supply and coal supply is traded internationally. That is really a big lever that importing countries can use to drive emission reductions. The European Union can set the stage for greater international collaboration. It can spur buyers to work with suppliers to reduce methane emissions along international fossil fuel supply chains. Now, getting the details right will be important. And we hope that the discussions today will contribute to this goal, and certainly the IEA will continue to support regulatory development to drive down methane emissions. Thank you.
Thank you very much, Thomas, for this comprehensive presentation and that has set the global perspective on methane emissions. And now I would like to present our next speaker, who is Ronald Kenter. Ronald started as a research engineer for development of natural gas metering techniques and statistical models for process control. He also worked as a technical manager for natural gas export, where he specialized in gas measurements and gas quality aspects. Since 2001, he has served as the environmental coordinator at Gasunie. In his role, he has been working in driving emission reduction programs and overseeing the measurement and reporting of emissions. His expertise is also international. He has contributed to standardization initiatives. He's actively involved in the European Gas Pipeline Incident Group, and he's chair of the MARCOGAZ Methane Emissions Group. And he's served also as the convener for the CEN-TC 234 working group in methane emissions. So, Ronald, the floor is yours.
Thank you, Virginia. Welcome, everyone. I just had a broad introduction, so thank you for that, Virginia. Today, I have a presentation on the guidance on the application of the EU regulation on the methane emission reduction. Maybe we can go to the next slide. The basic idea inside MARCOGAZ was to see how we could interpret the new methane directive in awareness of the cost and in awareness of the terms of the resulting impact of the emissions on the environment. For that, we had a lot of sessions to have interpretation of the different articles in the directive, and we made a document for this, and this document provides guidance in translating the requirement of the regulations into policies, and that can be used by companies, of course. Can I have the next slide? If we're looking at the directive itself, I think the directive is aiming for zero emissions. And what we did here was to make a sort of comparison to the already existing frameworks of the OGMP and how these issues were addressed in the EU regulations. In the OGMP framework, we have fugitive emissions. And when we look to the regulations, they are translated in leak detection and repair emissions. There's a second category in the OGMP. It's called vents. And this is addressed in venting and flaring in the EU regulations. And then there is a third one. It's incomplete combustion. So that would mean in the OGMP naming unburned emissions. And they are recalled in the EU regulations as venting and flaring. What I have to say here is that when we look into the OGMP, OGMP distinguished unburned from venting and flaring. That would mean every unburned emissions you have in boilers, etc. And the EU regulation does not do that. It's only saying something about the efficiency of flaring. Emissions originated from incidents are in OGMP categorized as spent, and the indisputed goal is to eliminate all emissions, bearing in mind that the burden for the society shall not be disproportional. And what the directive is doing, it's pointing to recital 10. And what you could see in recital 10 is that the necessary costs should not result in a disproportional financial burden on end users and consumers. Okay, could I have the next slide? The first thing I want to address is the directive, what it says about measurements, reporting, and verification. And what we could find in the directive at this moment, that it's crucial to determine to quantify all and report all methane emissions at source level. That would mean that you have to measure at your stations and at your installations. The second point is that the proper use of statistical sampling and engineering calculations should be used. So at the end, you can use engineering calculations, you have to do measurements, yeah, also statistical sampling is allowed when we're looking at the directive at this moment. At the end, it would mean that there should be a very transparent and traceable line of reporting. On an annual basis, we have to deliver a report with all our methane emissions, and this report should be verified by independent verifier. So verification is also an issue which will come to us. And what I heard lately is that also other parties are already involved in to see how this can be arranged. For example, ISO. OGP guidance mentions issues as not material and minimum emissions, and the directive does not do that. So the EU regulation doesn't mention explicitly materiality of the emissions. But on the other side, when we look at this, this materiality issues, I think, will be solved in the standardization process and the standardization request the European Commission already made. In addition to the source level measurements we are doing at this moment, we also should do site level measurements. And what we are looking for is, of course, if there is an agreement between the source level measurements and the site level measurements. And if that is not so, then we should think about reconciliation processes to be carried out. And that's something what is still in development, how to do that. But also for standardization, there will be some issues here. In the near future, the EU Commission will provide implementing acts what would give more specific rules and requirements regarding measurements and quantification. And what I can say here is that also within CEN TC 234 relating standards, these things are under development already. Okay, can I have the next slide? The third point to address is the mainly Article 14, what we have here. And this Article 14 is dealing with leak detection and repair. And what you see here is a sort of decision tree where you can find decisions you have to make. You find a leak. And I can strongly advise to read this because it gives some good guidance. What would be the actions you have to take when you find a leak? And I think when you look a little bit more closely to the scheme here, I will not discuss this whole scheme because otherwise it is too much time to discuss everything here. But if you find a leak and this leak is below a certain threshold, then you should check and change the leak within 3 months, that it's not growing and that sort of things. So that's, I think, the most important part. But if you find a leak above your threshold, that would be a different case. You have to ask yourself if an immediate repair is possible. If this is yes, you have to repair it directly and as soon as possible and survey within 45 days. When this is not possible, then there is a situation where you have to come and you have to ask yourself when repair is possible. And more or less, there was a question if a repair and replacement attempt within 5 days was possible. That would be Article 14.9. If that is not possible, you have to ask yourself if the full repair within 30 days is possible. And if this is not the case, then at the end you have to notify your competent authority that you could not repair that and that it will take longer to repair that leaks. I strongly advise to read this scheme because it gives some good guidance how you can interpret the leak detection and repair programs of Article 40. Okay, can I go to the next slide, please? And then we have Article 15 in the directive. And that is the directive which deals with vents. And OGMP categorized vents in operational emissions, purging and venting, that will be maintenance, process, commissioning, decommissioning. There's a group called the regular emission for technical devices. That could be, if you look into the gas industry, your pneumatic devices, your gas analyzers, your compressor seals, etc. Also a very important group are the starts and the stops. We have from our compressor, which also where we deal with unburned methane, and incidents and emergency situations. What is a very important article here in the article number 15 is Article 15.5 on the EU regulations, and it says that equipment, that vents, shall be replaced by non-emitting alternatives where those are commercially available and if they meet the standards of technical prescriptions for components designed to vent. And that would mean that you have to replace a lot of equipment over there, although maybe there are some equipment which are designed to vent, and that doesn't need to be replaced directly. I also want to point out that there the word equipment is not very well defined in the directive. And that there could be situations where you have to change something, you found a leak, but this is only a very small part of the total installation, and that would mean that you have to design and also to design your installation again, just by replacing this equipment. And in that cases, maybe a replacement may not be necessary. And we think that it would be a good idea that you discuss these situations with your authorities. What we actually also doing is that the standards in TC 234, Working Group 14, we are working on, and especially the standard for venting and flaring at this moment is providing also all kinds of apparatus and situations which are designed to vent, and that would mean that at this moment this is the best available technology we have, and this can be used also in future. And we think we will have standard there in approximately 3 years completed. Okay, can we go to the next slide, please? Also here we see a scheme for venting and flaring when we're looking to Article 15 directive. And you see here a sort of decision matrix, what you have to do. The basics for this is that venting more or less is not allowed, and flaring you can only do in special situations. If we speak about emergency situations, then in sometimes flaring can be allowed, what you can see in these schemes. So if you follow the emergency malfunction of Article 15.2 here, and you follow the yes situation, you have to ask yourself issues like, is recompression possible? So if this is possible, you have to recompress. If this is not the case, can you flare? If this is a yes, then there is a situation that you can ask yourself, does flaring lead to worse safety environmental conditions than venting? If this is a yes, then venting is allowed. If this is no, flaring is allowed. So there are very much specific situations which describes in this Article 15, where you can use this table in your decisions. Okay, can I have the next slide, please? Then there is something in the directive about the incomplete combustions. And we're speaking about unburned emissions from gas combustion devices such as boilers, engine and turbines. And they are not within the scope of the regulations. What is in the regulation is the flaring efficiency of 99%. In line with the definition of 31 in Article 2, emissions from gas combustion devices other than flares are not direct emissions and not considered as vented. That emissions are not subject to the consideration in Article 15 about flaring. And in line with the regulation, Article 70, flares shall have a methane conversion efficiency of at least 99%. Can I have the next slide, please? So then maybe at the end, some considerations from MARCOGAZ. We are strongly supporting a transparent reporting and remaining emissions and the execution of measurements that reduce methane emissions. MARCOGAZ, as well as OGMP, compiled best available technology documents to achieve that. The BAT documents will evolve according to technical developments and evolving practices. We also recognize the obligation to repair all leaks above a given threshold, but also that the clarification of the Article 13 stating that operators shall take the appropriate mitigation measures is needed. And for small leaks, this could mean where the emissions as the sum of scope 1, 2, and 3 of repair greatly exceeds lifetime emissions of the leak. So that could be a situation where you do not want to repair directly, and where the societal cost of the repair greatly exceeds the lifetime societal cost of the leak. If this is the situation, we suggest that you have an open discussion with your competent authority about this and what the appropriate mitigation will be. And it should be clear, in addition, that to the environmental impact of the emitted gas, this emission causes a small free scope emissions in the provision chains due to stream activities too. So what we suggest is not only looking if we find leaks, what a repair would mean or a replacement would mean only in scope 2 or 1 or 2 of the emissions, but also to look at the scope 3 of the emissions, because sometimes this emission can also be very large. And we think you also have to take that into account. Thank you for your time. I will be at the end of my presentation.
Thank you very much, Ronald, for the presentation. I would like to remind all the attendees that you can already put your questions during the presentations in the chat, and we will address them at the end of the webinar in the question and answer session. I would like to go now to the next presentation, more focused on the midstream application of the EU regulation. For this presentation, we have Emil Wegkamp. He is an asset manager within Hasuni with the primary focus on emissions reduction. He is one of the coordinators for the Internal Road to Zero Emissions program, where he is also involved in topics surrounding energy efficiency and more specifically in ELDAR. So please, Emil, the floor is yours for this presentation.
Thank you, Virginia, for your kind introduction and already the pavement of the way for the first presenters. In this presentation, we will take a look at more of the practical implication of the methane legislations for our company, Gasunie. It's a TSO that is operating a grid between 8 and, in some rare occasions, 100 bars of pressure. If you could go to the next slide, Virginia. I will first provide some background of Gasunie, the ELDAR monitoring protocol that we currently have in place and how it will look in the future with the new legislation, what the expected impact will be, repair policy, and how we had to adopt the new methane legislations, in particular on the repairing. So what Ronald already presented with venting, flaring and recompression obligations, and the abatement cost, which is more in line with what Thomas already presented for but then more applied to the Gasunie specific situation. If you could go to the next slide. Gasunie is a TSO. In that remark, we're also working with MARCOGAZ. We are operating in both the Netherlands and Germany. This, however, what you see on the right is our system that is evolved in the Netherlands specifically. We have our high pressure system, which goes from 40 bar to 100 bar, is about 6,500 kilometers. Could be a little more or less nowadays, but that keeps changing, of course. Then we have a regional system that's below 40 bars operating. It's about 6,000 kilometers. A lot of the impact of the legislation that we see, we'll come back to that later, is in the valve schemes, that are mostly on the ground, which we have approximately 3,000 of. 12 compressor stations, and currently we're operators on 1 LNG terminal. We have been gold standard certified for about 2 years now, 2 or 3 years. And for methane emissions are mostly in the vented emissions due to the compressor vent stacks and the dry seal emissions that we have there. Also a smaller part in the fugitive emissions. If you could go to the next slide, Virginia. Our ELDAR program, mainly the detection part at the moment, we are checking a quarter of our system every year. And when we find a leak, we go back there every year to check whether it's grown in size. And with the future intensity, we will only execute type 2 measurements because our systems were not accompanying type 1 inspections at the moment. So we are using type 2 inspections where we inspect all equipment for once per 4 months. This will lead in quite a significant increase in costs. So will lead to approximately 20 million years in expenses over the next 8 years, which is an increase of about 800% of our inspection costs. Please note that this is excluding pipeline inspections, since we are currently seeing very little leaks there. And if we see a leak, we expect them to show up in our central command post very quickly. We have been measuring valve schemes rather new activity. We have a first measurement campaign in 2023 and concluded that in 2024. And that's where some first analysis was made what the impact of the methane regulation would also be when we need to repair underground leakages mainly. And we've also done part of our system with site level measurements, drone measurements for mainly. We've also tried some satellite measurements, but found that it was at this moment very not a mature enough technology for our system. If you go to the next slide, Virginia. At the moment we have a new repair protocol where we're looking at trying to comply with the methane regulation. Of course, we use the valve schemes to block most of the part where we need to work. We can't work under pressure at the moment, of course. We are buffering out the gas as much as possible to reduce to a minimum pressure, so there's less to recompress, of course. Where possible, we are using nitrogen displacement to increase the front pressure for the recompression and the flaring. And the working efficiency of the recompression, we have made some adaptations to our recompression unit, which allows us at the moment to reduce up to 2.5 bars, where we need to flare or vent below that part. As is also shown here, flaring can be done till about 0.2 bars. Of course, it will take a bit longer than venting, of course. And we are also using bellowing systems to reduce the amount of pipeline that we need to get rid of the gas of. Okay, go to the next slide, Virginia. Yes. In practice, we have made some cases as well to see what would the additional costs be if we would do also recompression for the lower parts where you have to use flaring for. We have been seeing limited use of the recompression in our regional pressure systems, or medium pressure system as it's called here. We have mainly been using in our high pressure system. But as shown before, there are some possibilities to also use it here, which also can be done at a limited cost, which is expected. It's a capex that's below 1 million, and with an opex because there's more manpower needed to operate the recompression unit. That's about half of the quarter of the cost as well. But there's quite a good payback period, which we'll come back to later as well. So this is one of the options that Thomas also already mentioned that is quite interesting to also explore more for us, and we are currently trying to purchase also some smaller recompression units to comply with this. We go to the next one, Virginia. Yes. Then more of the research we've done on mainly the valve schemes. That's actually one of the main sources that can provide underground leakages. For above grounds, we expect limited impact with the methane legislation as it is right now, since we've already have quite a rigid inspection regime there, and repairing all leaks that we found above 1,000 ppms. For underground, it's a bit more difficult at the moment, because like I said before, we've been measuring quite recently. We have a new measurement campaign, as you can see here below. We found that a lot of the schemes we found were leaking quite often at a very low leak rate. For a high pressure system, this was almost 70% of the valve schemes we checked showed leaks that were above the repair threshold. The repair threshold for below ground leaks is of course the 5 grams per hour. That's the legislation as well. With a total leak rate of only 62 tons of CH4 per year. However, when you need to repair something on the ground, you need to, of course, have some digging up excavation activities. In the Netherlands, we also have very wet ground, so you need a lot of work there to be able to have a clean working area there. So that would lead to high societal costs. In this case, if you put it up between the cost per ton CO2, which is often done in these abatement activities as well, you come for the high pressure system to almost 2,000 euros per ton, which is of course quite a high above the ETS price at the moment. And to also prevent ourselves from causing more environmental harm than we solve with the repairs, we're also laying the last hand on the model we are using by getting like what Ronald already mentioned before, to get the total scope 1, 2, and 3 emissions of the repair and put them against the total scope 1, 3 emissions of the leakage, to make sure that when we need to repair something, it's above the repair threshold of 5 grams per hour. We are not causing more harm than good when we want to repair a leak. Because we have so much valve schemes that we're talking about, the total cost could be up to 350 to almost 700 million euros. Of course, there are a lot of parts here that might be subject to the environmental test, like I discussed before. You could go to the next one, Virginia. Yeah, this is mainly the slide that is also aligning with Thomas's discussion. We also see a lot of measures that can be taken that are due to limited additional costs or even negative costs. So some very small measures like pneumatic controllers, we can replace some. We can do some static recompression. We are looking into it for our dry seal emissions mainly, but other measures can be quite more costly, like mobile units for the very small recompression for mainly the part below 2.5 bars. If we want to do recompression there, we see quite limited possibilities there for emission saving, but quite high OPEX due to additional operators that need to be used for that. And for example, the fugitive emissions, we see a lot of there are quite some easy quick wins to say. The large leaks can be solved due to limited societal costs, and there are also a lot of small leaks. I think it's also discussed before in some sessions that we see like almost 20% of the emissions are 20% of the leaks are responsible for 80% of the emissions, and other way around. And we are focusing. We have to focus a lot of effort on the 80% of the leaks that only cost 20% of the emissions. To say, in our case, that's even a bit less. So that will bring high societal costs, and for the valve schemes, all the underground leakages, those costs will be even higher for even lower emissions abatement. And for now, I think that's mainly my presentation. The next slide did have some questions here, but I think we'll save those for the end.
Thank you very much, Emil, for your presentation. Yes, we will have time for the questions after. I would like to kindly remind again to the participants that you can send your questions in the chat, and we will address them at the end. So now we will go to the last presentation before our discussion. This time, now we go to the other part of the value chain, to the downstream application. And I would like to present and introduce Lilian Wietservin. She has held different positions within GRDF in France, and is currently chair of the downstream gas systems group in MARCOGAZ, and also she is the vice chair of the Methane Emissions Plus group. With more than 25 years of experience in the gas sector, she's skilled in regulation, governance, European technical affairs, and market intelligence. So, Lilian, the floor is yours for your presentation.
Yes. Hello, everyone. Do you hear me? Do you hear me fine?
Yes, okay. Yes, we can hear you.
Okay, great. So, thank you very much for the invitation to participate to this seminar. It's really a great honor for me to be here today. Previous presentations were very interesting as well. So thank you Thank you again for that one. If we start with the next slide, so I will start with opportunities rather than challenges for DSOs on the EU methane regulation, because I indeed think that the EU regulation on methane emissions leads to opportunities for DSOs. I would like to recall that DSOs have an extensive experience in detecting and repairing leaks, as safety and control of emissions have always been at the core of their operation. One of the reasons being that DSOs are in close contact with end users and operates in urban areas. So it's not something which is new for us. Also, the LDAR leak detection and repair processes that are currently used by the DSOs are adapted to urban areas and to specificities of the grid. Most of them are in line with the requirements of EU regulations, so it's a good opportunity to share and consolidate best practices on the detection and repair part. I think this methane emission regulation. And the side of quantification, it's not a new item neither. DSOs have developed methods to quantify their emissions, and they have worked on improving them along the years. Many DSOs are now participating to OGMP. So in this sense, the EU regulation can ensure a consistency in methodologies for quantifying leaks and gives the opportunity also to quantify the leaks in the same way, to monitor leaks in the same way, and to maybe be able to really monitor how methane emissions are decreasing. So that's on the opportunity side, I would say, of the DSOs. I will deep dive a little bit in the challenges on the next slide. Thank you, Virginia. So what I would like to underline maybe, and what the diversity of this panel illustrates as well, is that the whole gas value chain is concerned by this EU regulation. It was a strong ambition from the beginning, I think, that this regulation applies to all the value chain, being upstream, midstream, and downstream being the DSOs. And indeed, this is a strong ambition, because I'm not sure it has been reached somewhere else in the world this way. However, it raises challenges also, because DSOs are specific, are RNE operators, but of course very different from a compressor station, for instance, or from a LNG facility. DSOs are a very large number of DSOs in Europe, more than 1,300 operators in Europe. Some of them are very small, some of them are large ones, like in other countries, in many countries. And they represent more than 2 billion kilometers of pipelines. So it's very huge grid with many connecting points. They are very often local for a country or for a town, but not European extensions. And the grids are high density. They're made of buried pipe, mainly, small components, and in urban areas. So that's the specificities that we have as DSOs, and I think EU regulation generally accounts for these specificities. However, there are still some challenges that need to be addressed, and I will talk about them now. One of them, for instance, here are some examples. As mentioned by Ronald, the notion of site is difficult to apprehend for a DSO. What is a site for a DSO when most of the pipes, the assets are buried? What is a site level reconciliation when you can when drones cannot be really used in urban areas, or leaks are too small to be identified by satellites, for instance. So site level measurement methodologies and reconciliation are not mature yet. There are still work going on that. A little bit the same for source level measurements, because on-site measurements is not always feasible. Solutions still need to be developed. And talking about LDAR processes, indeed, the LDAR processes used by DSOs can vary a lot from one DSO from another, depending on their environment, on the distance to the source, sometimes being done by foot, sometimes by vehicles, sometimes by combination of both. So this diversity somehow might still need to be addressed in the sense standards and so on. Urban specificities makes also true that some methane emissions can come from other sources than the grid. So measurement and detection need to account for that. And last but not least, as I said before, many processes are linked to safety requirements, and all the equipment should be compliant with the one used for safety requirements and international operational processes. So there are still some work to do, and that's perfectly understandable, to develop standards describing best practices, while of course respecting absolutely the requirement of the EU regulation, but still providing diversity of solutions to be used. If we go to the last slide, so I will end with recommendations. So that's basically what I said before. Recommendation is to allow for sense standard to adapt to the specificities of the operators, while enabling a degree of freedom. So this is something which is going to start now. It's the next step. And also, it's important to account for market maturity. As I said, some solutions are still to be developed. So technical neutrality is key as well, to ensure that there are many playing field robust solutions, and that new solutions can be developed with time, and also to avoid restriction of choices in solutions which would not be necessary. So I think I kept the time that I was allowed. This is the end of my presentation. Thanks again for listening to me.
Thank you very much, Liliane, for this presentation. So we have come to the end of the presentations of today. So now we have time to discuss and to get your questions. about the presentations of today. For this question and answer session and to close the webinar, I would like to introduce Pascal Alas. Pascal has a 21-year background in Natran, which was formerly GRTGAS. Primarily, he has been a rotating equipment engineer. He's involved in the methane emissions mitigation field, and he is also a member in the MARCOGAZ methane emissions group for over 10 years. Pascal is the secretary of the CNTC 234 of Methane Emissions Working Group, leading the standardization project on venting and flaring limitation, and an active contributor also to the OGMP 2.0 task force. So Pascal, the floor is yours, and I invite everyone to put their questions in the chat, and we can have an insightful discussion.
Thank you, Virginia. Good morning, everybody, and thank you to our presenters for the very clear presentation. So let's jump to the questions. So that's a question from Juliana Caponegro, and that's a question concerning the reporting scheme. So maybe that's for you, Ronald, or any. Or if any of the other presenter would like to answer, that would be fine also, of course. The question is the following: similarly to what has been implemented for the EU emission trading system, is it envisaged that a single standardized model or template will be introduced for which each regulated entity will be required to report its emission and monitoring plan to the respective national competent authority? So are we going to have in that regulation a kind of united or unique reporting scheme? Ronald.
Yeah, that's a very good question. When I look to the emission trading system, then more or less your total CO2 emissions, you have a price for that. And that could be amount of euros per ton. So it looks also very good to the proportionality. As we look at the directive itself, the directive is saying you have to overcome your emissions, you have to repair that or replace it by components. And there is no direct relation at this moment to a sort of emission trading system at this moment. It's just you have to repair it or you have to replace it. And that at this moment, of course, if we look into the cost, what I already said, the cost should be not disproportional. And that is something that our companies like bodies like ACER are looking at that at this moment, but it's not the same as in the emission trading system. What I can say about the plans you have to do and to verify your emissions and that sort of things, yes, we have to deliver the monitoring plans to the authorities at this moment. But at this moment, there's no really a proportionality issue as what can be seen in the emission trading system.
Okay, Ronald, thank you. Thank you. Emil, I see that you popped up. Do you want to add something? Or?
Yes, if I understand the question correctly, it's also more about the model or template that needs to be used to provide the ELDA plans. And at this moment, in the Netherlands, we've only been competent authority has only been appointed for 2 weeks now. So we have not been able to get any template or whatsoever on how we need to hand in our plans. So if that's the question, at this moment we do not know of any standardized template or something that needs to be used. But we are, of course, very open to receiving one.
Yeah, but if I may on this one, except if somebody else from the presenter would like to intervene, this should happen at one point. At one point, a template will be defined, and that will be part of an implementation act that should be drafted by the Commission. So at the moment that will come, and what the regulation state at the moment is that before that scheme is defined, it is possible to use the OGMP template. I hope this answers the question. So this is a question from a DSO from Czechia, Andrzej Prno. Sorry if I don't pronounce this in the right way. And this is a question, so potentially that would be for you, Liliane, I guess. So the question is, we are able to secure LDAR detection requirement completely on foot, but we were advised by supplier of detection technologies on vehicle that if we want to fulfill the requirement of source level measurement, we need to use vehicles. What is your opinion on this topic, please? So the use of vehicle, if you can already do it by foot.
Yeah. I think this question fully underlines what I said before, is that all DSOs do not have the same the same processes, and it doesn't mean that some are better than others. And I think, well, it's my personal opinion that detection is one thing and quantification is something else. And it's true that I think many DSOs are used to detect in ppm, so they might use detection methods in ppm, and this is fully allowed by the EU regulation, which gives values in ppm and in gram per hour. And the quantification is something else. I said it's not mature yet, and I don't have much opinion. My only opinion is that it is still can be an issue for DSOs, because leaks are underground, and I'm not aware of any algorithm translating ppm to gram per hour, for instance. So it is a subject in itself. OGI camera is not working, but the regulation lets the sampling possibility using calculation as well. So it's still a topic, I think, on how to quantify. And one of the, maybe, I didn't talk about that, but there is an implementing act coming soon, which will precise Article 14 on LDAR and the type of equipment which can be used for LDAR. So the advice, well, it's to be able to use foot or vehicles for that. We will see what is really written at the end in the implementing act. But today I cannot. I think the question you ask is still not has any answer yet, in my opinion.
Thank you, Liliane. So we have more questions coming. The next one is from Nikolaos. The question is, what kind of organization are the competent authority appointed for EU methane regulation in Europe? Ministry or energy regulators? So maybe I can take it to my knowledge. These are from ministry, either environmental ministry that are dealing with on the environmental part, or energy. But I don't know if you have different Different views in the presenters? Okay, apparently not. Next question. Yep.
Depends. Depends. We have for our LNG terminal, for example, we have the local authority there that provides the well, the control, and we have a ministry that is checking our more global, the countrywide networks, for example. We have different authorities for different parts.
Thank you. Another interesting question from Giacomo Maggiore. I think it's yeah, that would be maybe for you, Lilian or Ronald. Emil, that's really a question for operators. So regulation do not clearly address the management of already installed devices. Anyway, it's a case in Article 15, but there is some question around that, especially those that reduce but not fully eliminate venting. Is it advisable to keep them in use until end of life first? Additionally, in a newer version of a recently installed device, if a newer version, of a recently installed device becomes available, should it be replaced immediately or retained until its life cycle ends? I think, Ronald, you spoke a little bit about 15 and 15.5, and that could be a good interesting question for you, or?
Yeah, very interesting question, but also very difficult to answer, I think. Yes, if new available technology comes available, should we replace it at once? I think there's no real clue at this moment when you're looking to the directive itself. So I think that should be a discussion you will have with your local authorities on this issue. On the other side, there will be some equipment that is vented or designed and still venting, that would be the best available technology at this moment. And that is more or less addressed in the CEN-TC 234 working group 14 at this moment, where you're the convener of this, or you're the chair of venting and flaring, Pascal, where we describe best available technology, which still can be used. And the question is it advisable to keep them in use until the end of life? Yes. I don't have a clear answer on that now. I think this will be subject to the discussion you will have with the local authorities on these issues. But we do not have jurisprudence on this.
Okay. Thank you, Ronald. Next question, and maybe that will be the last one. We'll see what time we have, Virginia. I think that could be for you, Lilian, because this is concerning DSO and level 5 and OGMP. So this is a question from Gianluca Ciola. Two questions in one, and that is regarding the calculation of methane emission following OGMP guidance. It is not clear for me, the level 5 details are not clear for me. Is it a level 4 plus a site level employing a Picaro system? First question. And second question concerning the N15446, where ppm from equipment leaks is converted into kilogram, without considering the pressure inside the equipment, which can be half a bar or 5 bar. Is that a level 5.2 or is that a level 3 or level 4 at the end of the day? Okay, can you address this question, Liliane?
I can try to give some elements, and maybe Pascal, you can help me on this one. So on the level 5 and on the I think the question is on site level reconciliation. So I said in my presentation that there are no mature solution for me on this one, and this was also pointed by Ronald. Because especially for DSOs, we are talking about buried pipe. So what is a site? It's a bit difficult to say. It can be a town, maybe. It can be a country. So first, everyone I think should maybe think on what is the site for them. But it's difficult to say. It's a portion of pipe. Well, it's because the idea is that you make measurements and there is another top measurements and there is reconciliation. And again, the top measurements, it's hard to see how it comes. We cannot circulate, well, drones can be circulated into towns, but on very specific occasions, once you have a bridge, for instance, on something like that. There are methanes which are not coming from the grid. So I think this discussion is open, and I'm aware of different R&D projects around that, at least one in France and one in the Netherlands. So there is, I know that in OGMP there are some discussions, so I think it's quite an issue. As I said, the ppm conversion to gram per hour for underground leaks to me is not really there yet. So there are many issues, and it's one of the subjects which to me still need to be worked out. So it's still for me an open question, and maybe not yet mature to be translated into a sense standard, or it can be maybe a recommendation, but it's a difficult question for me.
And for
maybe
DSO.
Pascal, yeah. And for DSO,
that's a difficult point for DSO, but maybe I can cover that on a more general point of view. Concerning the first question, yes, level 5 is level 4, so source level, which has been compared to a site level. And in OGMP, from your findings, you will derive what is called the L5 inventory that potentially will be the level 4 corrected with or adapted based on the level 5 findings. I will not, so I'm not a DSO, so I'm not a specialist in what Picker can do, so I will not go further. And concerning the N15446, yes, you are right. You will derive a kilogram per hour, whatever is the pressure, and this is based on correlation factor that were established in the US in the 90s. So this is not really corresponding to your DSO grid. And at the moment in OGMP is not level 5, is not level 3, this is level 4. If you look to the technical guidance on the subject. Okay, it's 12:26. Virginia, do I jump to the closing remarks or?
Maybe we can address the last question, as is the last question in the chat. There's time. We can
absolutely.
Step a couple of minutes. It's fine.
So the last question is from Mike Brenner, and this is the question for mobile survey. So it's again concerning DSO, I guess. For mobile surveys using vehicle and some of these newer technologies, what level of independent validation is expected to verify the accuracy of the coverage, leak detection that can be verified on site, the location accuracy, and the quantification accuracy to give DSOs confidence? Should we expect this to come from CEN or OGMP? Okay, so here we are about mobile survey, maybe more on detections and quantification. So I think we should answer that question based on the scope of the CEN standard that we are building. So this is LDAR and quantification standard. Ronald, can you take it, or Liliane, concerning the level of verification concerning these mobile surveys and the link with the standard?
Yeah, maybe just a general remark. The story is not fully written yet, because indeed there are standards coming after this regulation, and the compliance of the standard will ensure, as I understood, the compliance with the regulation. And the standards, they will make several years to be written, 3 years in principle. So what is not written in the regulation will need to be written in the standards, and the discussion is starting, in fact. So that's why we think we don't have yet all the answers to this question. It's a general comment I wanted to make to inform everyone. Ronald?
Maybe I can say something about that. The reconciliation issue will be addressed in the CEN standard, and we are working very close together with OGMP to give some good guidance on how to do that, and what your uncertainty will be if you do such a reconciliation. It's a very difficult question at this moment. It involves a lot of statistics. It involves sampling procedures. How much should you sample to have a good quantification of your sites? And also the problems that we still have is that a top-down measurement more or less is very often a snapshot at a certain situation in certain conditions. The question is, how do you compare that? So this is still worked out by OGMP and by CEN, and I expect that we come with in the CEN with some further guidance on how to do that and what should be delivered. But it's still an ongoing process, and it's not very clear at all points at this moment. But there is a standardization request coming from the European Commission to give some guidance on these issues in CEN study.
Yeah, and maybe to add up on that, here we are in the field of quality assurance check and concerning this measurement methodology, and I don't think OGMP is at that point yet of detail. But within CEN there is of course TC234 that work on this stuff, but as you know, Ronald, we have a link with TC264 which is concerning air emission measurement technology, and that may and will be involved to address this question of let's say quality checks on the methodologies that are applied. So, but fully agree that's still an open story, an open book. Okay, if there is no more question, maybe we can wrap up. And one question: can gas leak caused by third-party damage or reported by warnings be classified as venting events, or should they be considered part of fugitive emission? It's a good one for you, Lilian. This one.
As I understood, gas leaks caused by third-party damage are incidents.
Yeah.
So for me, they go to the quantification part. Do you agree, Pascal? It's incidents, so it's also an issue. Yeah. Incidents are also an issue to report them, because of course we cannot, for safety reasons, incidents should be stopped very soon, and safety preempts the quantification part. So measurements, it's very, very difficult on incidents.
Yeah. You know, GMP, you are right. I see the last comment. You are right, Chris. You know, GMP, this is vent. But it's not completely clear what it will be in standards, I guess. But not sure it is completely defined for the in the future standards.
Okay.
It does not. This is not very clear when it's a vent or fugitive emissions, and OGMP is very clear on that. That's a vent, and so it's part of the discussion, I think. It's still going on.
Okay, still going on.
Yeah. Okay. Yeah. So maybe to wrap up. So thank you all for the very clear presentation again, and for the questions. So today is the first presentation, and typically the one from Thomas reminded us how undisputable is the methane reduction necessity, the methane emission reduction necessity, as it is technically achievable, and in a large enough proportion to significantly and quickly impact the global warming. So even if, as said, also methane emission mitigation is not something new for the gas infrastructure, and that some progress and significant reduction were already done in the emissions. Now, the methane emission reduction regulation is driving the natural gas sector on that route. So fully agree with Lilian that that regulation is clearly an opportunity. This is an ambitious regulation that is now applicable from 1 year. During that year, the challenges, the associated challenges have been identified, and in a large proportion assessed by the stakeholders. So there is different kind of challenges for the infrastructure operators. There is, of course, technical challenges, because even as said, if gas infrastructure operators already apply diverse methane mitigation measures, and for quite a long time now, which was done in voluntary basis, these practices are not harmonized. that's a field where there is still a lot of research and development, and standards are still to be set. There is also challenges in terms of resources for gas infrastructure operators, if resources that are finite by nature. So this will require prioritization, and all this in the regulatory framework that does not allow much freedom degrees. So of course that's a challenge, and we will face also some potential impacts in terms of operational continuity, and this will challenge our organization. Having said so, the regulation is in place since 1 year. Now it's time for implementation. And we are at the defining moment, as at the moment there is the drafting of the going by the European Commission of essential implementing acts. There is also discussion between CEN and the Commission on the scoping of the standard that will complete the regulation. And there is already launched key interaction between the stakeholders to do that implementation, including national authorities and regulators. So that's a moment where sound approaches of the regulation should drive pragmatic decision from these parties and stakeholders in order to make that regulation effectively applicable, and like this it will be a success. So at least to keep that the road we are on straight, even if the slope will remain steep. So that's it for me. Thank you for your attention, questions, time, and I will give back the floor to Virginia.
Thank you, Pascal, and well, thank you again to all the speakers and presenters today for their insights and for answering also the questions, for everyone that attended the event. And I would like to remind everyone that the recording of this webinar and the presentations will be very soon available in the MARCOGAZ website. So I will wish you all a very good day and a very good weekend as well, and see you next time. Thank you.